Our next step is to create the table, and when you see this, you're gonna see why we want to do this as a tabulated drawing. You got a little bit of idea behind tabulated drawings with the shafts. Now we're gonna really show the power of how you can use these tabulated drawings. So the first gearbox that we made was a 4-to-1 ratio. That's this one. And it's 4-to-1, and it's made out of a module number 330.19. That's what I put in my log. Made out of 330.19, but then there needs to be an end shaft, some number of transfer shafts, and a nut and bolt pack. So this tells me about this gear module that I'm making. And then I'm going to have to add on to it an end plate, a shaft, which in this case, the quantity is going to be 0. I don't need a transfer shaft because I don't have one to transfer to, and a nut and bolt pack. Okay, so that gives me a 4-to-1 ratio. But then I know that if I put two of those together, I get a 16-to-1. So my first piece, and notice that over here, I don't have any 1B or 1C. There just aren't any. It would just be made out of this piece, plus the end plate, plus the bolt pack. But now when I go on to my next one, I want a 16-to-1 option. And that would be a 330.19 and another 330.19. Of course, it's put in upside down. And that's 4x4 is a 16-to-1. And once those two were put together, I would need to put on my end plate. I would need one transfer shaft between this gear and my drive gear from part number 2, and I'd need a nut and bolt pack. So there I'd have a transfer shaft of 1. But you can see this is building it up so somebody can read this and make a bill of materials. But this has to have its own number. When I put this pack plus this pack plus an end plate plus some bolts together, that is a different part number. It would have a different amount of material and cost and labor, and it would just be a different thing to sell to somebody. So that would have its own part number. And you can see what I did here. I added a part number line. So it's for a reducer. That one's not a reducer module, actually. It's a reducer final assembly. Because it's got modules plus the other stuff in it. Okay, and so I might even have this moving on too. I would actually need a 330.23 would be my reducer final assembly for a 4-to-1. So let me go correct that up here. That's a 21, 22, and I think I've got it as a 23 in mine. Yours will be in whatever order you've put them in. So that's my reducer final assembly. It's made out of one of these modules plus an end plate plus a transfer shaft, so on and so forth. So that's kind of cool. See how that works. And then I could make a 64-to-1 made out of one of these. Now, the trick is I can think of other ones that I could make. How would I make a 24-to-1? Well, let's see. 24-to-1 would be a 4x3x2. That would be one way to do it. 4x3x2. So if I had a 4-to-1, I had a 4-to-1 and a 3-to-1 and a 2-to-1, that would be 12 times 2 is 24. And this is what we were working on last week in our discussions of setting up other gear sets that worked on the exact same center line so we could pack these together. How would I make a 27? I think that would be a 3x1 and a 3-to-1 and a 3 to 1. So you can see with just a few different things, I can get a lot of these put together.